Study of chemical science, and I think I heard something like atoms and all that stuff.
Atoms, reactions, and molecules.
Any other collective definitions as a class? Or you're like, no, that's pretty much what we decided on. But how does that apply to biology then? Why would I start here? If it's the study of chemical science, atoms, reactions, molecules, so what?
Because all living things obey the laws of chemistry and physics.
Okay, all living things obey the laws of chemistry and physics, so you should probably know some of the laws of chemistry and physics. What are all living things made out of? Cells. What are the cells made out of? Atoms. So what is chemistry the study of? One of the things you listed here is atoms, right? Chemistry, the textbook definition of chemistry, it's the study of matter and the changes matter undergoes. So at that instance, I have to ask you guys, what is matter? And this you know, you memorized it in like 7th grade. What is matter? Anything that takes up space and has mass. So anything that takes up space and has mass. That means you. That means Squirt. That means your desk. That means your planner. That means like everything, right? Can you find something in this room that does not count as matter? You seem unsure. You want to say it confidently? Are you confident? Okay. I won't make you say it confidently. What do you guys think? Does air take up space?
Yes.
How much space?
Lots of space.
Okay. Light. All you had to do is say it confidently. Energy, right? Energy is not matter. So we're not going to talk about, in this instance, we won't talk about energy. We'll talk about transfers of energy, but energy is not matter. Sound waves, not matter. Thoughts and ideas, not matter. But everything else we talk about is matter. So we have to talk about it here. What did you say for atom? You should have a good collective class definition for atom. What's an atom?
The smallest building block of matter makes up everything.
Well, this is where it gets called a liar again. It makes up everything. What's it look like?
It has a nucleus, and then there are like electrons.
You are still squarely. Sauer has informed me the Jimmy Neutron generation. And I'm going to tell you that Jimmy Neutron has actually lied to you because you expect an atom.
It looks like a Mickey Mouse, right?
You expect it to look like that.
Yeah.
This is what Jimmy Neutron has told you.
True.
That is not what atoms look like. It is accurate that atoms do have a nucleus. And that nucleus is in fact composed of protons and neutrons. So if you saw protons and neutrons on some people's whiteboards, accurate. I don't ever write protons and neutrons. This is the first time I'm going to tell you, the first time of very many times I'm going to tell you, scientists are basically lazy. If we can abbreviate it, we're going to. So the abbreviation for proton is a lowercase p with a superscript of a plus and a lowercase n with a superscript of a 0. That tells us what their charges are as subatomic particles. Now I just called them by their official name, subatomic particle. Sub means below, atomic, the level of the atom. So these are smaller than atoms because they make up atoms. They compose atoms. The electron cloud is the second part. So part 1 is the nucleus, part 2 is the electron cloud. And you'll notice another abbreviation, lowercase e with a superscript of a negative. It tells us what charge that has. Jimmy Neutron would lead us to believe that electrons orbit a nucleus of protons and neutrons. And that is absolutely true. But that model leads you to believe that it's on a fixed path, right? That's what those rings mean. It's going to go around and around and around. And for those of you who have seen Hoodwinked, I will give you a much more accurate description of how electrons behave. In Hoodwinked, you know that little squirrel that gets caffeine, like it has coffee, and it runs all over in an exceptionally unpredictable and quick way? It's a movie, for those of you who haven't seen it.
The second one is that.
Always it happens that way. For those of you who are unfamiliar with Hoodwinked, I will give you a slightly, well, it's helpful but unhelpful because it is a fixed path. You've all seen a fan operating, correct?
True.
And you've seen the blades spin.
True.
When the blades are spinning on that fan, at any given point in time, can you tell me where the fan blade is?
No.
Like you can't.
Depending on how fast it's spinning.
Think about it. What does it look like? It's like a blur, right? Like a propeller. And if you were going to attempt to locate it, as soon as you located it, it would have moved on. How do I know? Because you're going to stick your fingers in there. Do not go home and stick your fingers in a fan. You stick your fingers in there in an attempt to locate the fan blade, and as soon as you locate it, shortly thereafter followed by the word ow, and hopefully not anything more colorful, and a buzzing noise. After you've located it, it's moved. It continued on. That's true for electrons. We can never actually predict where they are because they're moving in random motions. So we can say it is highly likely we will find them in this region. So we call the region the electron cloud. And we like the term cloud because it tells us that where the cloud is more dense, it's more likely to find an electron. And where it's less dense, it's less likely. But it's just a probability. Most of the electron cloud, empty space. Just like that blur of the propeller blade, most of the time, it's empty. There is not a propeller there.
But if you can't locate them, then how do you know they're not on a fixed path?
Well, there is actually this fabulous equation that is pretty cool that tells you the highest probability of finding it based on calculus. So the reason why I tell you that there's a math requirement to be in this class is because in order to send you on to chemistry next year, you have to have the math that you need to be able to understand those equations so you can predict where electrons are. I know, you're just like, suddenly you're like, what? Yeah, that's why I have that rule. It's like I thought ahead or something. The frequent description of an atom that I give you if I'm trying to draw it to scale, you guys know a shooter marble, the big marble of the marble set? If I were to put it at the 50-yard line of the football field, that would be like the nucleus. The electron would be somewhere near the track itself, and it would be about the size of the tip of a pencil. And it would be orbiting out in that region. Most of the rest of the atom, just like most of the rest of the distance between the nucleus and that electron, it's empty. Mostly empty space. It's really hard to think about because you touch yourself and you're like, I feel pretty solid. I don't feel like all that much empty space. Mostly empty space. Craziness, right? Now, I will tell you, atoms are the smallest particle of matter that retain its identity. So if I were to remove an electron from an atom, it would no longer have the same identity. It would be something else. So we have to be a little bit specific about that. Smallest building block that retains its identity. What did you tell me for element? Can you tell me about an element? Hope I didn't just break that, which I did. I heard it. Thank you.
The thing I have back off this.
What can you tell me about an element?
Raw material in its most basic form.
Raw material in its most basic form? What else can you tell me? Where can I find a whole list of them? The periodic table. So if you consider it the periodic table of the elements, you are absolutely correct. It is the periodic table. But an element has a fixed number of protons. So it's an atom with a certain specific number of protons and electrons. Atom with a specific number of protons and electrons. If I change the number of protons, I've changed the element. If I change the number of electrons, it's no longer an element. It's an ion. So it has a very specific number. A fixed number of protons and electrons. There are 118 known elements. $90 of them are naturally occurring, the rest are synthetic, man-made. And we abbreviate them typically with 1 or 2 letter abbreviations. There are some at the very end of the list, some of those synthetic man-made ones that get 3 letters, like unalquadium has a 3-letter abbreviation, but most of them are 1 or 2 letters. Now I have to warn you, and sorry ladies, I have to kind of accuse you of this one. When we abbreviate elements, we always do so with the first letter being a capital letter and the second letter being a lowercase letter. And if you recognize this particular pattern of writing from when you were in about the 1st grade and learning how to make letters, where the 2 lines on the outside are blue and the one in the middle is a dashed pink line to teach you the scale of how to write your letters, this matters here. So if I were to abbreviate sodium, the element, I would write capital N, lowercase a. The vast majority of the time, the people who fall victim to doing this thing that is incorrect, it's usually the girls in the room. Just because I've written a lowercase letter the size of an uppercase letter does not make it a lowercase letter. That's not sodium. Nor is this. Okay, so we know to be one kind of element, you have to have the same number of protons. Protons are how we define what we would call the identity of any element, is the number of protons it has. In fact, that number is so important, I liken it to a number that you all have. It turns out that shortly after you were born, your parents were attempting to celebrate your birth in the hospital. They were so happy and life was good and they're holding you. And then these people from the government come in and they say, I need your child's name and I need all of this information. And your parents are like, hey, we're still taking our moment to name our kid, go away. And they badger you until discharge to provide a name for your child. The reason is they don't really care about your name. What they actually want is your information so they can submit it and make sure you get a social security number. That's what they're actually trying to do. That will assist them in making sure that you are a good law-abiding, tax-paying citizen in the future. The U.S. government does not consider you by your name. They consider you by your social security number. Why? Well, because your name, there's probably more than one of you. The example I often use is my college roommate. Her name was Erin Smith. She was one of 6 Erin Smiths at the University of Michigan. Not in the country. One of the 6 at the University of Michigan. She was one of 3 Erin A. Smiths at the University of Michigan. So, pretty generic, pretty common. How did the university ID her? By number. How do we identify any element? It's by number, by atomic number, not name. So we prefer the atomic number. What's that correspond to? The number of protons in the nucleus. There are 118 different choices. 118 different elements. We start with one that has 1 proton in its nucleus, and we go all the way up to 118. Now, because they have different numbers of protons, they also have different numbers of electrons. In any element, in any atom, protons equals electrons. So in any atom, the number of protons will equal the number of electrons. That's going to tell us a lot about their behavior. They behave the way they behave because of the number of protons and electrons they have. But before we can talk about their behavior, we have to familiarize ourselves with the most common ones in biology. Some of you guys probably already know some of these, and some of you are going to look at me like a deer in headlights. And if you don't believe me, the deer in headlights freezes and does this. I guarantee you they do. They stand there with this like, and you're looking at them, you're like, not that hard to move, but they still stare at you real funny. You okay? Misspelling? That's rough. He probably doesn't have whiteout because he doesn't even have a pencil.
Just scribble it out. It's fine.
Some of us can't just scribble it out, okay?
Then learn. First you take the pencil, put it on the paper. And then
So there are going to be 20, I think there's a list of 20 elements that are the most familiar in biology that I want you to know. We'll go through them, but my recommendation is whatever app you have for making flashcards, you'll probably want to enter them into that app as we go. Why? Because there's a quiz on them on Monday. I was just giving you some advice.